Good afternoon, grade 11 students. We are going to record our mathematical induction, lesson number 9. So here is the principle of mathematical induction. Let P of n be a property or statement about an integer n. Suppose that the following conditions can be proven. We have 3 steps. Step 1, show true for n is equal to 1. This is the base case. Step 2, assume true for n is equal to k. This is the inductive hypothesis. And step 3, show true for n is equal to k plus 1, and that is the inductive step. Let's start with example number 1. Prove that 1 plus 2 plus 3 plus so on plus n is equal to n times the quantity of n plus 1 over 2. Okay, so for step 1, show true for n is equal to 1. Let's substitute n to 1. That's for step 1. So this part here, we are going to substitute 1, 1, and 1. So here it is a given, and then we'll substitute n is equal to 1, and then n, 1 times the quantity of 1 plus 1, quantity divided by 2. So that's the substitution method. Next, 1 plus 1 equals 2. So 1 times 2 is equals to divided by 2. The answer is, by simplifying, we have 1 equals 1. That means n is equal to 1 is true. Okay, so let's go for the second step. Assume true for n is equal to k. This is the inductive hypothesis. So we are going to substitute k to n. Let's change that to k. So here is the given. We are going to substitute n to k. That becomes k. All n's becomes k. Next, let's show true for n is equal to k plus 1. This is the inductive step. So let's have the given, this one. We are going to change the n into k plus 1. So here it is. Instead of n, we will write k plus 1. The n here becomes k plus 1, and the n here becomes k plus 1. The next step would be, we are going to substitute this part here, the 1 plus 2 plus 3 plus so on plus k, which is equivalent to this part, k times the quantity of k plus 1 divided by 2. So that becomes the equivalent, and then we'll add the k plus 1. Will we equal it to this part here? We just copy paste. The next part is, we are going to get the least common multiple, the least common denominator. So we'll just add 1 plus 1, because we are going to simplify this part here. So that becomes 2. So let's copy, and then 1 plus 1, that becomes 2. Copy the denominator. Here, we are going to get the LCD. So that means 2 is our LCD. 2 will copy the numerator. This part will become 2 divided by 1 is equal to 2. And then multiply it by the numerator. Alright, copy the right side. And then we are going to simplify this part here by distributive property. So k times k, k squared. Then k times 1, k. 2 times k plus 2k. 2 times 1 plus 2. Let's copy the other side. Next would be, we are going to add the similar terms. So k plus 2k is 3k. Copy, copy, copy the denominator. And then we are going to use the FOIL method, or katong the perfect square binomial. So we will have k times k squared, k times 2, 2k, plus k times 1k, 2k plus k is equals to 3k, 1 times 2 is equals to 2, copy the denominator. So therefore pag yun, this makes the step 3 true. We have the conclusion now. Therefore, the formula is true for all positive integers n. Thank you very much for listening, and let's proceed to example number 2.